Good evening, everyone. I'm Professor Andrei Zvelindovsky, Head of School of Mathematics and Physics at the University of Lincoln in United Kingdom. Very warm welcome to everyone who came to our mathematics chat. I'm very pleased today to meet in this mathematics chat with Professor Alexandre Borovik, who is a Professor Emeritus at the University of Manchester here in the United Kingdom. Alexander was a professor of pure mathematics at the University of Manchester from 1998 till 2020 when he retired. Alexander remains active both in research and also in the field of mathematics pedagogy, mathematics education in varieties of social contents. He is also very interested in history of mathematics, and that will be a topic of today's chat, which is dedicated to Hedy Lamarr, remarkable woman. And of course, today is 8th of March, and the choice of topic is not a coincidence. Welcome, Alexandra, to our chat. Very good to see you here using this video link. And now I will give floor to you for your presentation. And just before we start, I'll mention that as traditional in all our charts, they live, but they will be recorded and people can watch them after. We have 1 hour. First there is a presentation, and then will be time for questions, which you can type directly in YouTube, and I'll read them to Alexandra after his presentation. Floor to you, Alexandra.
Thank you very much. I'm very honored to talk here on this remarkable topic. Well, without wasting my time, let me open my presentation. I hope you see it now. Yes?
Yes.
Yes. Okay, so my presentation is about Hedy Lamarr, a remarkable woman. And a purely not just unbelievable, bizarre history, which happened at the beginning of all this communication technology, at the various early stages of development of communication technology, namely invention, spread spectrum approach to communication. So this is my talk. I start directly from what was done. First of all, what we are talking about now, it is a technology which is used in mobile phones and Wi-Fi. As it frequently happens, people are using technology without having any knowledge what actually is happening inside a smartphone, for example. Definition from Wikipedia. Spectrum techniques are methods by which a signal is spread in the frequency domain. They are used for secure communications, increasing resistance to natural interference, noise, jamming, to prevent detection, and to enable multiple access communications. As can be seen immediately, here is a mixture of security applications, of military applications, defense against jamming, and normal everyday life of normal humans in peaceful time, like smartphone. This is a multiple access communications, when many smartphones can be connected simultaneously to the same mast. And it is the basics of our life now. This is about Hedy Lamarr, who was a Hollywood star and who remarkably made an invented frequency hopping, moving communication from one frequency to another. And the social problems, the social issues, the psychological issues behind that are truly remarkable and deserve attention. It is obvious that she was a very beautiful woman. She was a Hollywood actress when it was necessary for a movie star to be very beautiful. She was voted by movie critics at one point the most beautiful cinema actress in the world. What has happened that in these Hollywood circles, there is a strange mixture of emigres from Europe, because war is already was happening in Europe, World War II. In 1940, she met at one of the social occasions in Hollywood a composer who was earning his living at Hollywood by writing music to movies. George Antheil. In Europe, he was famous for music for the film, for example, Ballet Mécanique. And he was one of the innovators who was in the new technological environment of the 20th century, was trying to develop music as it could be produced by machines. In particular, he had the technical experience in all these electrotechnical things, and he knew the state of the art and handled the state of the art devices created for music. It started like a romantic affair. She scrolls her phone number in lipstick on the windshield of his car. But remarkably, it was not. Because Hedy realizes that George had crucial technical expertise. He writes music for the player piano, electromechanical piano, and knows how electromechanical piano works and how similar musical devices work. In particular, devices which play pre-recorded sheet music, note by note. It was called player piano. If you look at this picture, the title of the journal is Spread Spectrum. This is a professional journal of specialists in communication technology, which celebrates the work of George Antheil on occasion of his jubilee. This is their patent. Maybe I will try to increase the size. Yes, to the maximum. Can you read the name? H.K. Markey. Markey is Hedy's name in her second marriage at the time. The patent is awarded in August 11, 1942, at the time when America entered the World War II, after Pearl Harbor in December 1941. And I'm trying to return back to show you something. Yes, I did. It is here. I'm coming back. No, I cannot. Can I? Yes. Patent filed June 10, 1941, when America was not at war. It was at the peak of isolationist stand of America in international policy, when it refuses to get involved in the war in Europe. Talking about war was not very popular at the time in America, especially for women. and especially thinking about weapons for this future war. Hedy did this because she was waiting, expected the war to start. And she perhaps was better informed on that than many people around her. And interestingly, what her invention was is about controlling a torpedo by radio, which remarkably increases the chances to get into the target when operator from a ship can control torpedo using radio. The problem is that it could be effectively jammed by the enemy. And she realized that solution to that is frequency hopping, moving communication from one frequency to another in a manner unpredictable to the enemy. Again, let me put it here, yes. What basically she realized is that transmitter and receiver, as I said, have to switch from one frequency to another synchronously. And Antheil actually knew how to do that, use the switching gear of a player piano. And the sheet music, if you wish, written in some scrolls in the communication device on the ship and in torpedo, read from the same sheet and switch synchronously from one frequency to another instead of playing a note. They simply jumped to another frequency. Well, what happened next? Invention was duly ignored by the Navy. What do you expect from Navy folks dealing with the actress and the piano player? But during World War II, Hedy became propaganda fodder when it was necessary to convinced as many people, as many women as possible to work at military production, at the production of ammunition and arms at ammunition factories. The technology was reinvented, of course, because it was needed in the 1950s for missile guidance systems. When mobile phones nowadays is a much more advanced version. Rather than hopping, the signal is spread over frequencies. There is one medium, however, where hopping is still preferable to spreading. This is a very low, relatively low frequency communication or signaling in water, in the acoustic domain, not in electromagnetic domain. These ideas exist in more or less same form as they were in Hedy's time, simply because of very different physical environment. We shall return to that. Meanwhile, I have to explain who Hedy was and why she known in history of Hollywood not only as a leading actress in movies, but also famous for her independence of mind and her witticism, very disrespectful, very frequently. She was basically a rebel, which is quite strange because she was born in the classical bourgeois environment of Europe. In 1915, Hedy Kaisler in Vienna, Her father was a banker, quite a rich man. Her mother had good relations in arts and in newborn cinema and the theater. So for that reason, at very early age, Hedy got involved with filming. In 1933, she was the leading actress in the highly controversial, by the standards of the time, film Ecstasy, which made her a superstar, and which perhaps attracted attention to her future husband, Fritz Mandl, very rich arms manufacturer in Austria. 1933, she was 18 years old when this happened. Perhaps her family were happy to dispatch her to marriage before she will be involved in some other scandal around films. Well, Mandl was pathologically jealous. He forced Hedy to sit with him at business meetings just to keep eye on her. So for that reason, she had to spend long hours in extremely boring meetings. On the other hand, she lived in the golden cage. The wealth and the influence of her husband brought her into the high society of Vienna, and the high society at the time had the real meaning of high society. So she learned a lot, as we now understand. Be particular, apparently, she was impressed by conversation what to do with these torpedoes, and that the men around the table didn't know the answer. Well, she also learned, sorry, my voice, that the name of the game of her husband was illegal, in breach of Versailles Treaty, rearmament of the Nazi Germany. She was quite disturbed by that. And there is a legend that she dragged her maid and escaped through the window in her maid's dress. And moved to Hollywood, where, as already said, she got reputation of extremely strong and independently minded woman. To give some idea, it is quote from her. Any girl can be glamorous. All you have to do is stand still and look stupid. Oops, sorry, I moved. Further developments. Here I want to show just a little bit of mathematics involved, because this mathematics, on one hand, is extremely elementary, but also is quite non-trivial. Again. In the 1940s, frequency hopping technology has been independently developed by Navy in America and maybe in some other places for use in sonar systems. Sonar is underwater radars which used acoustic, sonic waves rather than electromagnetic. Frequencies here are much lower than in electromagnetic, and also sound waves moved much slower than speed of light, of course. And so for that, reflection from moving objects change their frequency. Doppler effect. It is the classical change in the pitch of the sound of a train, of a locomotive at the train when it passes by platform. Sonars are critical for everything which related to submarines, because they use for navigation, for measuring distances to target. They use for communication between submarines and with ships on the surface, for detecting objects and measuring their speed by using this Doppler effect. Fantastically, as it happens, the first use was by Leonardo da Vinci. He discovered that if he put a tube into water and hears on the other end, he can hear the sounds of rowing, oars meeting, moving in the water. Sonars basically sends a series of sounds of different frequencies. The same sequence can be repeated many times. And this is a very crude diagram. Horizontal axis here denotes periods of time. And on vertical axis, marked frequencies of sounds which are produced by sonar in this particular time. I intentionally used the simplest possible pattern. When it reflects, the sound reflects, echoes from an object, it returns shifted in time, because time passed. And for example, here it was originally issued sequence of sounds. It comes with delay by one period of time and looks like that. But the same can happen with Doppler effect. If it is reflected from objects which moves away, the sound comes back in lower frequency. And if this was the original sequence of sounds, this is what has happened. If they, after reflection, come back by in lower frequencies. The trouble here, if we get these reflections, what is that? Reflections from a distant stationary object, or a much closer but moving one. Solution. Send signals of frequencies arranged in time in such a way. Look at this rather intricate pattern. That any horizontal shift or any vertical shift or any combination of them would produce no more than one ping in common from what was sent and what was received. In this case, it will be possible to identify very clearly what actually was happening. Returning here, In one case, echo. Echo produced by a different way. We can say nothing about from where they got reflected, whether it was moving object or stationary object. Simply because they simply coincide. They have intersections, how many of them? 5 nodes in common. Well, playing with this thing, you can very easily discover that actually, if no matter how you move this pattern, it intersects with itself, no more than in one ping. Remarkable, but how produce this patterns? Well, manually trying to guess what it should be is remarkably difficult. I showed you some pattern in the field 7 by 7, because here 0 is present. So altogether there are 7 rows and 7 columns. Or more precisely, actually, it is 6 by 6, because 0 here is not used, as we can see. 6 by 6 pattern. And but for example, it is open problem. Where are so-called these Costas arrays exist for tables of size 32 by 32. It is open problem since late 1940s, when American Admiral Costas formulated this problem. And I will explain now, using just remaining 2 minutes of my talk, how one can come to this array, the one which you wish. We have to use heuristic thinking. One of its formulations, if all you have is a hammer, everything around you looks like a nail. Try to use what you know, in the hope that this will work. Assume that we know only elementary calculus, standard school calculus, and treat it as a calculus problem. Array is a graph of function y equals f at x. We're simply interested in the graph only in special points 1, 2, 3, 4, 5, 6. It is well-known property of graphs of functions is that we shift graph by 8 units up, or by b units to the right. So we are getting a graph of the function which transformed by this rule. It was y equals f at x, and here y equals a shift up, and plus the original function f, but evaluated at the point x minus b, where b is the distance of the shift to the right. Well, which function to use? And I bravely use exponent. But since we have to do everything on the size of the square 6 by 6, exponent, normal exponent, quickly goes very up. I take exponent to the base 3. 3 to 4 equals 81. And 3 to 6 I even did not care to compute. To fit it back into this small square, you have to replace each value by residue by division by 7. 3 remains 3. 3 squared equals 9. It's 7 plus 2. So we write 2. 3 cubed, 27. It's 21 plus 6. 21 is divisible by 7. it is discarded. 7x has 0, and the 0 could be written here if you wish, 7. And for that reason, ignored. And it can be computed that 3 to 5 equals 5. And 3 to 6 equals 1. Okay. Now we reverse this function, producing logarithm model 7. And the same calculation which was done before is rewritten as logarithms to the base 3. Please notice that all values here, again the same 1, 2, 3, 4, 5, 6. And here they repeated 1, 2, 3, 4, 5, 6, the same numbers. It is one-to-one permutation. And all identities for algorithms and for exponent remain, interestingly. Our pattern is exactly the graph of logarithms model 7. If the graph and the shifted one intersect, which means that log x equals a plus log x minus b, we do high school calculus thingy, exponentiate both paths and getting this equation in the form x equals 3 to a times x minus b. This is a linear equation and has at most one solution. It means that intersection of this graph and shifted graph has no more than one point in common. This solution was invented by Edgar Gilbert in 1965 and independently by Lloyd Welch in 1982. Why independently? Because all the stuff was kept classified, because it was done for military purposes. But mathematics, underlying mathematics for construction of this particular thing is remarkably simple. Just say a few words. Mathematics for communication, number theory and elementary number theory, division with remainder and modular arithmetic, in effect, was used here quite prominently. Functional analysis, much more sophisticated than high school. And serious one like Fourier series and probability theory and statistics. A lot of mathematics in here. Mathematics inside of smartphone is beyond reach of graduates from most mathematics department in most universities in the world. But at the beginning, extremely simple ideas, as we can see. Well, exercise for the reader, for the listeners, for the audience. You may wish to try to build similar arrays using other prime numbers or maybe powers of prime. For example, 9 or 11, or do all the computation model 17. And finally, one of the sayings by Hedy Lamarr: I would love to see young people care less about hair and more about brains. They may not know it, but brains show as much as hair does. That's it. Thank you very much for your attention. And I perhaps have to switch off my slides. Yes. Thank you very much.
Thank you very much, Alexandre, for this talk about this story involving absolutely remarkable lady who left her mark both in movies and in basically everyday's life. and of course, this very kind of unusual way. How did it happen? Now we have time. We open for questions, and everyone can type the question in a live chat on YouTube. And I would like perhaps to start by asking myself. It is interesting. You mentioned that Leonardo da Vinci was first basically kind of recorded using sonar. And as I remember, then I read about his various inventions. Surprisingly, many things he proposed being also guided by military, basically applications. He lived in times of difficult, very difficult times. If we look on dates. And Hedy Lamarr also contributes something which now has application mobile phones, but that was kind of sprung due to thinking about this torpedo problem. What can you kind of say, how it is possible that this kind of development in science and application, which could start kind of with military application, but then find in our peaceful life the pathway as well. Can you maybe comment something on that?
Perhaps we have to remember that this is a sad part of human history, that surprising proportion of all inventions, whether in mathematics or in other areas of life, was done first of all for military purposes, because this was an area where the rulers, people who have power and money, were prepared to invest the stuff. The story of mathematics, arithmetic, was developed and considerably, and in times of Sumerian kings 4,000 years ago. And basically it was needed, first of all, for tax collection and for keeping accounts of the army. This was one of the places in the world where regular armies was first created, and they had to be fed, and they have to be provided with dress, with arms, and with stuff like that. And this required an army of accountants. And arithmetic developed together with accounting. And first of all, for the needs of the states, for the needs of the army. So for that reasons, the most basic stuff comes from this kind of applications. Steel is another interesting example. Only during Industrial Revolution, people start to care about steel produced specifically for specific parts of and tools and machines and stuff like that. Before that, it was development of steel for swords and for and completely different kind of steel or iron, maybe more correct term for that, for all this protective gear of knights, and because this new different these two forms of iron had to have completely different properties. You have to be able to shape soft iron around human body, and at the same time you develop steel which can cut through this soft iron. Alas, trigonometry was used both for design and construction of buildings, and for destruction of these buildings by artillery, by shell fire.
Right. I see there is a arriving question from related to life sciences. It's from Steph T. Is asking, is there any mathematics exploration solutions relating to whales using sonic communication?
Well, basically, all I heard is only very sad stories. Is that the what is called beaching of dolphins or whales is caused by them going in mad by noise of sonar communications between submarines and sonars. The problem is that they are using exactly the same frequencies like dolphins for their sonars, natural, for targeting fish and catching it. And in case of big whales, much lower frequencies for communication between them. The problem is the sound of that, it is claimed. At these frequencies can travel in the ocean for hundreds of miles, which makes it attractive for use for communication between submarines. And of course, this is a whales were using. Whales have very sophisticated social life. They are sentient beings like horses or dogs. They lived in stable married pairs for life. They care about their young and they attract their mates by singing. And their song is spread hundreds of miles around. So very frequently technology might have unexpected consequences for nature.
Thank you. I wanted also to ask a question. When you showed the last solutions for sonar communication, you mentioned that this solution been found independently in 60s and 80s. How much is different from what Hedy Lamarr kind of done?
Basically, most likely, what was important for Hedy, she was caring only about Gemini. And so for the reason, the problem is becoming very much simpler. You simply have to produce a sequence of nodes which are somehow immediately recognizable, in a sense, so that cannot be easily jumped. And a professional composer essentially could produce this kind of designs, diagrams, and so this could be done without mathematics, but with the experience of music. You know, mathematics and music, they are, yes, siblings, in a sense.
Thank you. And a part of this work on frequency hopping, is it known that did she try anything else related to technology and mathematics?
I don't know, to say the truth. I just by chance at some point to notice Costas arrays and stuff like that, simply because I was looking for some discrete mathematics problems, you know, from point of view of pure mathematics, and discovered a few remarkable, you know, stories around that. And
There are questions come in from William Segerstrom. Didn't Hedy pass away in a rather cantankerous state due to the lack of her scientific recognition and failed relationships?
Well, you know, the start of your life was such that actually she was perhaps cannot overcome personal problems all her life. She was married 5 times, at least, and perhaps actually indeed she was personally deeply damaged psychologically by the end of her life, and whether she cared about her invention, perhaps she did. At least she remembered about that. And perhaps she was quite bitter about lack of recognition. And this is what is happening. You know, she was one of the first women he was trying to venture into areas where women were not present, absolutely. And she was one of the first. And for that reason, maybe her life was so difficult. All her story is the story of the fantastic of liberation of women. After all, even she was from a rich family and in principle independent, you know, could expect to be sufficiently independent in life, but was reduced to the role of a trophy wife. By nowadays, by the standards of nowadays, it is just unbelievable. But unfortunately, this was the time.
And her work also, you said, it was classified basically. But did it become open during her lifetime that she?
Perhaps yes. Perhaps yes, because the patents had some periods when they had to be classified, stuff like that, and when it became clear that actually they're not of any further practical interest, these were declassified.
Okay.
By now, we have a lot of this declassified stuff from that time, and at the same time, it is an abnormal system actually for mathematics. The situation when mathematicians work in secrecy creates a very abnormal situation for them when they cannot share their thinking with others. And it is equivalent of writing papers, for example, and never publish them. Sooner or later, we are losing control on what you wrote. Is it correct or not? And working in isolation is not normal thing for development of mathematics.
Right, I have more questions here. Question from AC. The use of sonic waves for oil exploration is usually generated by some type of explosion. Would there be an advantage from the use of such frequency manipulation for this application?
Oh, I doubt. The reason that if you try to implement technology of the kind which is used in noise blocking headphones for that, and try to take this headphone and expand it to the size of, you know, covering industrial installation, I think that this is economically feasible.
Thank you. I now see quite technical question from Timur. What does the Wi-Fi or Bluetooth range depends on? why a lot of Wi-Fi networks at the same place don't affect on each other?
Because actually because their signals are filtered by in a rather tricky way, and this is a very sophisticated mathematics which is used there. And in particular, you definitely have to know Fourier analysis. And this is the minimal requirement which is needed. So if Timur wants to learn more about that, and he perhaps have to study, or maybe he's already studying, so I don't know, but he and this requires a very serious study.
And just as you mentioned, actually, study, it wasn't entirely clear to me what actually education Hedy got herself. She was from very wealthy family. She got some good schooling, but did she get anything further than that?
This question, which I was always much interested in that. But I suspect that her education, maybe she had good education in the sense of various kind of arts and in languages. But it would be extremely rare, extraordinary, if she also got any education in mathematics and physics.
So in fact, she was to some degree kind of just educated, or just kind of extraordinary.
Yes, she was self-educated, and she was simply developed the habit of thinking about things, essentially, and this is truly remarkable, because people who think, people who see problems everywhere around, not just problems, but problems which can be perhaps somehow approached and solved, and who identify critical configurations, bottlenecks, and all that stuff. This is critically important. Unfortunately, school does not teach this kind of stuff at all. And this is a pity.
I kind of talking about this again. There is a scientific. She certainly was. There was comment from William Segerström. Scientifically, she really was. And there is a question from William Pyre. At only 5 years of age, she could be found taking apart and reassembling her music box to understand how the machine operated.
Mm-hmm. Yes, it is quite possible, and there are remarkable cases when children developed skills, and exactly at this level, just by looking at stuff and playing with it.
And what kind of so to say, conclusion can be drawn from this remarkable story of Hedy Lamarr and her contribution in mathematics, in fact?
First of all, the strong message that girls in disciplines like mathematics and physics, they have to be welcome, they have to be encouraged. They can do mathematics and they can do problem solving well at the same level as boys. And the problem is that they are conditioned quite frequently in to be, no, how to say, to stick to more soft subjects. Also, girls are not supposed to be aggressive. You know, for invention of stuff for torpedoes, you have really to start thinking about. You really had to have strong desire to participate in a battle. Again, historically, she was a refugee from Europe. And so for that reason, Joe, as well as Georgia, Antheil. And of course, for that reason, they were prepared to think and to talk between themselves about that.
Yeah, so she definitely wanted to contribute to the victory.
Yes, of course.
Very strongly.
Yes, yes, indeed.
And wasn't really used all power of her intelligence towards that.
Mm-hmm.
And that was kind of story of the past. And doesn't give us lessons now for our life nowadays in school education or in mathematics teaching?
Well, yes, it gives. Basically the situation that if a child shows some ability for this kind of stuff, he or she had to be encouraged, provided opportunities, provided sufficient interest in learning materials, you know, at a more advanced level. And basically, they should, it is dangerous. It is a crime, actually, to keep, in mathematics, to keep a child bored, in effect. Not giving him sufficient food for thought, sufficient, you know, and interesting and exciting problems.
Thank you. Thank you. I see there is comment again or suggestion from AC. Another unrecognized woman genius was Elisa Meitner. So perhaps this is something for future talks. I think our time is approaching the clock, so we are 1 minute away. It was really educational to listen and chat about this absolutely remarkable lady, her not easy pathway to produce such a kind of marvel of mathematics. Yeah, with quite kind of military application first, but come to our life in like mobile phones. There is comment also from William Pyer, just last one. Hedy, she also studied birds and fish to get ideas for airplanes, which she showed to Howard Hughes, who expressed his approval. So definitely she was quite thinking person in various ways. Thank you very much for all comments and questions, for coming and listening. And thank you very much, Alexandra, for this talk and teaching us a bit of, as you said, trivial mathematics, but still it was quite challenging. So thank you, and have a good evening to everyone.
And thank you for everyone who asked questions and made comments. It is very important for me. Yes, thank you.
Thank you.